day, everybody, and we are back again together. And it's so good that we've been working so hard, these past few weeks. And I hope that you won't break off the momentum. For those of you who, have been doing your best to study and to prepare for the exams, right? And to the IB candidates, please, all the best for your exam this coming week. And we'll make sure that we plug you in for paper 2. But today I wanted to just check out, I just want to take you through the physical science paper 1 from the DBE, the Department of Basic Education. And we'll be looking at just the multiple choice section. Of course, you know how we roll. We're just going to try and break it down, and we'll be going into other sections as we go along. All right, so if you haven't subscribed, please just be part of the family. And please, for those of you who need assistance with mathematics or physical science, please don't hesitate to just give us a shout. And our email address is info@mlungisinkosi.co.za. All right, now let's get into the multiple choice section of this paper. And so the first question on the multiple choice section says the rate of change of momentum of an object is equal to the, right, now if you kindly remember, this comes from an equation that we normally use, and we say F net, okay, let me just bring that down a bit, okay, F net is equal to change in momentum divided by change in time. This is the impulse momentum equation, right? Now, obviously, if we say the rate, it's always division by time. So we're talking about the rate of change of momentum. In this case, obviously, that's going to be equal to the net force. So our answer to the very first one, I'm sure you got that, okay? The net force acting on a body, and that should be B, okay? Right, so the second one, let's move quickly. It says the gravitational acceleration on the surface of planet X with mass m, radius r is g. Now, ladies and gents, when they give you these kind of questions, so essentially, we need to kind of derive a relationship between all of the things that they've given. So they're telling us we've got a planet X, so g, which is the gravitational acceleration of planet X, is equals to, now of course we know that we've got the gravitational constant, the universal gravitational constant. So it's the mass of planet X, which is mass m, divided by the radius of that planet, which is r, but remember this is squared, right? Now, they're going to make a change here. They say the gravitational acceleration on the surface of planet Y. So this is another planet, okay? Now, let's leave that as G, okay? So this was the gravitational acceleration on planet X, remember. Okay, so they say another planet, which is planet Y, has with a mass of 2m and a radius of half r. Now, I'm going to call that gravitational acceleration. If you don't mind, I'm going to call it gy, right? So they want to know what will be the value of gy in relation to g, right? So in this case, what are we going to change? We know the mass is no longer m, but it's going to be 2m. So it's 2 multiplied by m divided by the radius. We no longer have r, but we've got a half of r. Okay, so that's 1 over 2r, but remember we square that. Now let's try and work this out such that we'll be able to get that back. So we know that multiplication is commutative, right? That means that we can order things around and it still gives us the same product. So this is 2g m, right, at the top there. All I did was to bring the 2 this side, divided by, now remember half squared, that would be 1 over 4 r squared. Now what I do is let's try and get rid of that fraction there because I want to have a coefficient and I want to have something that looks like this at the top. So in this case, let's multiply by the the inverse, right? The inverse of 1 over 4, of course, that's going to be 4 over 1. But what I do at the bottom, I have to do at the top. So I'm going to multiply by 4 over 1 at the top as well. So of course, this cancels that. So 4 times 2 at the top gives me 8. Okay. Remember, this has cancelled out. So I've got 8gm over r squared. Now you note in this case, remember, what was gm over r squared? This was g, right? Okay, so this, it means that gravitational acceleration on planet Y is actually 8 times g. Okay, right, so in this case, which one would be the correct option? Of course, that will be option D. Okay, right, hope that makes sense. Okay, as we swiftly move along, all right, I'm just going to bring that there. So they say the graph below shows how one of the physical quantities associated with an object in free fall changes with time. Okay, they say the label on the y-axis is omitted. Ignore F friction. Now they're asking which one of the following quantities, physical quantities, can be the label of the y-axis. Now remember, first of all, you're looking at a graph of something that is constant with time. So when you think of gravitational or vertical projectile motion, what remains constant? Okay, remember, velocity changes. Remember, time changes. Okay, time can never be constant. Okay, remember, everything else changes except the value of the acceleration, the gravitational acceleration. So in this case, that's the value of the gravitational acceleration. But what is related in this case to the gravitational acceleration? Okay, of course, I'm assuming the mass would remain the same, right? And in this case, obviously gravitational acceleration remains the same. So it means that the weight would not change in this case because it's mass multiplied by gravitational acceleration. So the correct answer there can be C. Okay, right. I hope that makes sense. Let's move on to the next question. Or maybe perhaps before I move on, the reason why I didn't choose velocity, of course, I did explain that. Position, I think it would go without saying as well. We chose weight, but I just wanted to explain this part for momentum. Remember that momentum is related to mass and velocity, right? So of course, whilst the mass doesn't change, velocity does. So it would actually affect the momentum. So that's why I wouldn't choose D. But when it comes to weight, both mass and gravitational acceleration remain constant. So as a result, that's why we chose that as our option. Okay, right, let's move on. Right, so the next question says, a ball of mass M falling vertically downwards hits the floor at a speed V. Okay, so that's our first speed there. Okay, and they say, and then it bounces vertically upwards at a speed of 0.75 V. Of course, that would be an inelastic collision because obviously kinetic energy there was not conserved, right? Because the speed actually changes. All right, so now we want to find out, okay, which one of the following combinations regarding the change in momentum of the ball during the collision is correct. Okay, now I want us to do this one in a way so that we can explain it. Okay, so if you think about this ball, so here's a ball falling down. They say just before it touches the ground, it has a velocity v, right? But then it bounces. Of course, it's going to touch the ground and then it bounces off. Okay, so this is when it was getting to the ground and this is when it's bouncing off. The velocity is 0.5 v, right? Now I want you to think about it. Okay, of course they said the mass of the ball is m. So what we need to do is to always choose a direction as positive. So I'm going to take downwards as positive. Okay, you can choose either up or down. It's really up to you. Okay, so if we wanted to find the magnitude, remember they were looking for the change in momentum, right? So we're going to say, well, what is the change in momentum? So the change in momentum is mass multiplied by the change in velocity, right? So this is going to be the mass. Now I want you to please note, this is going to be final velocity minus initial velocity. Now, most of the time when people substitute there, they forget that the final velocity is the velocity after the bounce, after it collides with the ground. So my velocity final is what happened afterwards, which was 0.75. But remember, it's in the opposite direction. So in this case, it should be negative because I've chosen down as positive. So that's minus 0.75 v, right? Minus, in this case, there's my minus there. My initial velocity was given as a positive v. Okay, so if you note there, I'm going to end up with minus 0.75 v minus v, which obviously both are negative. So I'm going to add them and keep the sign. So in this case, I end up with minus 1.75 mv, right? So now, first of all, what does that negative tell me? It tells me the direction because I've chosen down as positive. So it's telling me that the change in momentum that was experienced by this ball is first of all upwards, right? And its magnitude is 1.75. So in this case, I would go with C as our answer. So it means 1.4. We're taking C. All right, we are moving swiftly. All right, let's go to the very next one. They say the base unit of the physical quantity work is, now please remember, what is work done? Okay, so I'm just going to try and squeeze it at the bottom there. We know that work done is the product of a force and a displacement, right? Delta x, or yeah, delta x, right, in the direction of the force. So in this case, it's force multiplied by displacement. Now you remember that force is actually mass times acceleration, and the reason why I'm going that route is because I can see the options that they've given me there are in terms of kilograms and meters per second, or whatever the case is. So what is force? Force is mass times acceleration, but what's mass? Mass is in kilograms, right? Acceleration is meters per second squared. Okay, forget about that. That becomes just a factor, right? So in this case, multiplied by displacement, which is in meters. Okay, so you can see that when you take meters and meters, you multiply them, you get meter squared. So this will be kilograms meters squared per second squared. Okay, sorry, that's the equivalent of a joule, right? So that's kilograms meter squared per second squared. Sorry for that ugly handwriting there. Okay, so in this case, it means that for 1.5, the correct answer there should be option I think option C is the correct one. Remember, this is per second squared, so it's minus 2 there. So in this case, I've got C as my answer. Okay, right, I hope that makes sense to you. Right, you know what, just for the sake of being able to work out, I'll try and let me answer the next ones in on the other side. Okay, right, I hope you don't mind that. Okay, so let's answer 1.6. They say the siren of a police car moving in front of a truck emits sound waves of frequency f. Okay, they say both vehicles are traveling at the same constant velocity. Okay, now they say the frequency of the sound heard by the driver of the truck is, okay, I would actually go with option 1, which is F. Now remember, what causes the Doppler effect? It's when there's a there's relative differences in velocity between two objects, right? So in this case, they're telling us both of them are actually moving at the same velocity. So in this case, I would say that the frequency that is perceived by the listener, okay, in this case heard by the driver of the truck, should be actually the same as the frequency that is perceived by the police car. So in this case, what would be our answer? So for 1.6, I would just simply go with F, or well, A is my option. Almost wrote F there. All right, as we keep moving along. Okay, 1.7 says two identical metal spheres, P and R, are on insulated stands, carry different charges. They say the spheres rather, are brought into contact and then separated again. They say if one of the spheres, if the charge rather of sphere R after separation is Q, right? They say the charge on sphere P after separation is, all right, now please, I want you to note, whenever you take two charges and you bring them into contact with one another, okay, what's going to happen is that they transfer charges one to another. Obviously, if they are identical, they will transfer charges up until the magnitude of the charge on each sphere is exactly the same. Not only the magnitude, but also in this case the polarity, right? So it both will have the same charge. So obviously it goes without saying our answer here. So if after separation the charge on R is Q, so also on the other one P, our charge should also be Q. So in this case, our answer to 1.7 should be A as well. Okay, right, and then the next question, they say an AC generator generates a current of with a frequency of 50 hertz. Now you know frequency is the inverse of time. So they say the number of times that the maximum, that is the peak current, is produced in 1 second is, okay, so let's try and work that out. We know that frequency is 1 over the period. Now remember, when we talk about period, this is the time that it takes to complete one full cycle, right? So in this case, it simply means, now I'll explain that. So this is 1 over 50. Sorry, we want the period rather. So T is 1 over frequency. So we've got the frequency in this case, which is 50, right? And that should give us 0.02 seconds. So it means to complete one full cycle, okay, we will actually use 0.02 seconds, okay? Yeah, so to make it simple, we just simply say, so this is the time to complete one cycle, right? But it means that in 1 second, that's what hertz means. It means we are able to complete 50 cycles, right? Now think about an AC current. So you'd have a graph that looks more or less like this, right? Now remember that if this is one full cycle, you've got two peaks at every cycle, okay? People have a tendency to think, now this is the only maximum. Remember, this is also a maximum, but in a different direction, right? So you've got two peaks every cycle, right? So in this case, they are asking us, what is the number of peaks that we will have? So if we've got 50 cycles and we've got two peaks in each cycle, then it means that our answer there should be D. I hope I've simplified this or made it understandable enough. Okay, right, let's move on to the next question. All right, moving right along, they say in the circuit below, they say the battery has an internal resistance of R and an EMF of E rather. They say variable resistor R is connected in the circuit, so there's our variable resistor there. Okay, and the emitter and the voltage register readings, right? Now they say the resistance of the variable resistor is now increased. Okay, so they want to know which one of the following combinations is the correct representation of the change in the readings of the emitter as well as the voltmeter as the resistance is increased. Now I want you to just quickly note something there. So I want to do something quickly. So when we change resistor R, now I want you to remember from Ohm's law, we know that I is V over R, isn't it? So an increase in resistance, okay, what does it do to the current? Of course, it's going to decrease the current. So it goes without saying that current is going to decrease, right? When we increase resistor R. Now, to talk about the voltage reading, I want you to know this voltage reading here is actually the external voltage. Okay, if you think about it, the EMF, that's the voltage inside the battery there. But remember that it is subjected to a loss due to the internal resistance. So what we actually do is to say, well, but EMF is V external plus V loss, and I want you to understand this, or you can call it V external plus V internal. All right, so what we're going to do is, let's represent V external there. V external is equals to EMF minus the V loss, okay, or V internal. And remember that V internal is I multiplied by small r, which is the internal resistance. Now, I want you to please note, what have we done to the current? You remember we said the current does decrease, isn't it? So remember two things that remain the same here, both EMF as well as R remain constant. Okay, so because they remain constant, in this case, when I decrease the amount of current, guess what happens to the value of V loss? That decreases. When this value decreases, okay, remember this stays the same. When I decrease the internal voltage in this case, then what will happen to V external? Our V external should actually increase. Think about it. EMF stays the same. Let's just take a value. Let's say this value was 12, okay, and the initial internal resistance was 2, okay, or the internal voltage rather was 2. So if this value stays as 12, okay, let's start there. 12 minus 2 would actually be 10, isn't it? So it means our V external would be 10. But if this value now, V loss, actually decreases, let's say now it becomes 1, okay, so my V loss becomes 1. So 12 minus 1, what does it give me? It gives me 11. So it means that by virtue of decreasing the internal resistance, of increasing rather the external resistance, okay, we decreased current, but that decreased the internal voltage, and that will obviously increase the external voltage because EMF stays the same. So we know the emitter reading, we said it will decrease. So let's look there. Okay, we've got two options, decrease and decrease. But the voltage reading, we said it will increase. Okay, so let's look for an option with decrease and increase. So that should be A. All right, so 1.9 option there is A. Hopefully that makes sense. All right, as we move to the next one. All right, so the last question on the multiple choice section, they say the sodium cathode of a photocell is irradiated with ultraviolet light as shown in the diagram below. They say the emitter registers a current. Of course, it means that electrons are emitted from the cathode. Right, so they say which one of the following changes will increase the emitter reading? Okay, so we want to know what will cause the current to increase. All right, Okay, so they say use a thinner sodium cathode. Okay, we don't have evidence of that. They say increase the intensity of the ultraviolet light. Now, please, I want you to note when we increase intensity, okay, what happens is that more electrons are emitted per second. All right. So once you increase intensity, what you are actually increasing is the power. Okay. Then we are emitting more electrons per second. All right. So in that case, what it would do is it would increase the value of your emitter reading. Remember, when we talk about current, we say current is the rate of change of charge, isn't it? But in this case, what have we done? We are increasing the amount of charge that we are emitting per second, okay, and as a result the current also will increase. But let's look at the other options. C says increase the frequency of the ultraviolet light. Remember, when we increase that frequency there, what it does is that it will just increase the speed of the electrons that are emitted. All right, you still emit the same number of electrons, but they would just be moving faster. Okay, and the last option, they say replace the sodium cathode with a cathode with a lower work function. Okay, so again, when I take a cathode with a lower work function, all right, it simply means that if I maintain the same frequency of ultraviolet light, it means now it's able to emit, okay, in this case electrons, rather, the maximum kinetic energy. Yeah, perhaps you don't even understand what I'm saying. Let's just write it down there. So E is equals to omega 0 plus Ek. So remember, what I am doing is I have decreased the kinetic energy, sorry, the work function, right? But in this case, let me write Ek as the subject of the formula again. So Ek is equals to E minus omega 0. So if you think about it, when I decrease the work function, okay, remember E stays the same. So when I decrease that, it's almost the same thing that happened in the previous example. So when I decrease the work function, so my kinetic energy would increase. Again, the speed of the electrons are increasing, all right, but the number would, more or less be the same. So in this case, my correct option there for 1.10 should be B, where I increase the intensity of the ultraviolet light. Okay, right, and essentially that is how we arrive at all our answers. Okay, I hope that has been really helpful to you. I know it looks like a monstrosity that we've done here, okay, but I hope it will help as you prepare towards your exams. And please don't stop working hard, ladies and gents. And I'm grateful to hear of all the wonderful improvements that you guys have been making. And I hope that you'll continue working hard and get those distinctions. Yeah, I mean, of course you deserve it, right? And by the way, please don't forget to subscribe to the channel. And please continue to tell others that, hey, look, we are going for that target of 20,000, 50,000, 100,000. Hey, let's go for it. Why not? Because we understand the more of you that are on this channel, the more you are assisted in terms of your preparation for physical science. Otherwise, I'll see you guys next time. Sharp.